All right, rather than just sharing it in front, if you could turn to your new partner and see if between you two, you got the answers. What would be the answers to this warm-up question? All right, for Road to Excellence, for you and your new partner, raise your hand if you got this answer. What is the answer to this equation? We got new partners here. Jake, what's the answer? So that's it multiplied out. Awesome. I'll give it to you because you multiplied it out correctly. If you had multiplied this out, you would get x squared plus x minus, what did you say? I think 6 is what you said. So yes, I'll give you that for having it multiplied out, but it's not quite solving the equation. So let's go to another group. Derek. Nice. If you're looking at what would make this equation equal 0, you would have to set both of these equal to 0 and solve. You would get x is equal to 2 and x is equal to -3. Now, just expanding actually on what Jake said, if you were to graph this on your calculator, so if you, instead of putting this in for 0, you put this in for y, the way that those solutions would show up at -3 and at +2. And the graph would end up looking, well, it would have hit that like this. Now I can't draw because of Mr. Max thing. I need to move that over there. Okay, so what I want to point your attention to is these values, really if the equation is equal to 0 and you solve them, they're specific locations on your graph. They're your 0 values. They're going to be where the graph crosses the x-axis. That's going to be really important for today's understanding. So I just kind of wanted to throw that warm-up question there. All right, now let's continue building our understanding from yesterday. So yesterday we learned that the degree and the leading coefficient of a polynomial determines the end behavior. So go ahead and write that in. The degree and leading coefficient of a polynomial determines the end behavior of the polynomial. It's been a while since yesterday, so let's make sure we can go back and revisit and see how. As a quick reminder, we learned this yesterday. If it's an odd degree polynomial, you know the ends are going to go in opposite directions. The leading coefficient plays a really important role because if it's positive, it's going to go down, up. If it's negative, it goes up, down. If it's an even degree polynomial, it's going to go in the same direction. Again, the leading coefficient, if it's positive, they go up, up. If it's negative, it goes down, down. Do you guys remember that from yesterday? Yeah. Okay, good, because we're still going to be using it today. And we're going to be focusing on a little bit more of graphs as well. And specifically, the degree to the polynomial determines the zeros. And remember, zeros are also known as the roots of the graph. Okay, so today we're going to use our acquired knowledge that we learned yesterday. And we're also going to take out our calculator just for this first one to make some observations of how would I graph an equation that's given to me like this. So go ahead, take out your calculator. Mine's pulled up, awesome. And let's see what we can do based off of what we learned yesterday. Here we're asked to sketch the graph of the following. The first thing I want you to make note of, this is given to you in factored form. So basically, if we were going back to that warm-up question, Jake gave me the equation in standard form. That's really what we want to think about when we're looking at what's the degree of the polynomial. I gave you the equation in factored form. When it's in factored form, it's easier to solve for the zeros. So that's just kind of really something important to make note of. So when I'm looking at this equation and I say, what is the degree of this polynomial? You want to think about it multiplied out. Now, you do not have to actually multiply out the whole thing. The only thing you have to think about is what would be the leading term? What would be the x times x squared times x? What would that term produce? So as I'm looking at that, I would think about what's x times an x squared times an x. What would that create if I was multiplying this out? X to the fourth, awesome. And would it have a positive leading? Yep, because this is positive. So from yesterday, we would have a positive leading coefficient, degree. So that's going to allow us to determine the end behavior. How will the ends of this graph be facing? It's an even degree polynomial with a positive leading coefficient. Up, up, nice smile. So we would just go ahead and write up, up. Now the next I have somebody online, so I don't want to miss them. Skylar, are you still with me? Can you hear me? She's on chat. Okay, awesome. I'm sorry. I'm not sure if I lost you, but it like went wacky for a moment.
Oh yeah, it is. Sorry, I think it's my internet.
Oh, it's all good. Okay, so the y-intercept, guys, you should be able to know how to do this. I know this was a question on the placement test. So if you forgot, let's make sure we remember, how do you find the y-intercept of any equation? What do you do? Do you remember? Y-intercept is always where something equals 0. Do you remember what? Good, it's where x equals 0. So to determine the y-intercept of any equation, even this quartic polynomial that was given to us, I'm just going to plug in 0 everywhere I see the x. So I would have y is equal to quantity 0 minus 2 times quantity 0 plus 1 squared times quantity 0 plus 3. And now I'm going to figure this out, multiply it out. 0 minus 2 is negative 2. 0 plus 1 is 1. 1 squared gives me 1. And then 0 plus 3 gives me 3. What's negative 2 times 3? Negative 6. And then what would this be as an ordered pair? Good, 0, negative 6. Okay, now I'm going to use this information and I'm going to create the graph of this equation. The first thing I'm going to start with are my zeros. I know where this graph crosses the x-axis. It's going to cross it at 2. It's going to cross it at -1. And it's going to cross it at -3. Now, those are the only places the graph crosses the x-axis. So I know the ends of the graph. There's no other zero that's the left of -3. So at that end, I know the graph is going to go up. Same with the right side of the graph. There's no other ending zero after 2. So I know that that is going to go up. The other point that I know it's going to pass through is I know that it's going to have a y-intercept of 0, -6. So I know that this graph is going to have to hit the y-axis at that location. So that gives me a little bit of direction of how to finish this graph. I know that the graph has to hit this y-intercept. I know that it, sorry guys, I'm like losing my voice. I know that it has to hit that 0 as well. But here's the thing, I don't know if it's going to pass through that 0 or if it's going to just bounce off and create like a parabola. So this is where for right now, I'm going to take out my calculator and I'm going to see what happens right there. So in your calculator, you don't have to multiply it all out. You're just going to write it or type it in exactly as you see the equation. So our equation is quantity x minus 2 times quantity x plus 1 squared times, what's the last one? X plus 3. You might have to press zoom 6 if your window is zoomed in from the other worksheet. So I know my window is off, so I'm going to go ahead and press zoom 6 to take me back to a standard window. And now I can see this function. I was pretty close in my sketch. I went down, I went to -6. I didn't go further down, but right now we're just looking at a sketch. Hi. You're fine. So 3.3 part 1 is today, 3.3 part 2 is tomorrow. Synthetic division and the remainder theorem is tomorrow. Yes. Yeah, no problem. Okay, so guys, what happened at that 0 at -1?
It went down.
It went down. So let's go ahead and let's mark that. It does not pass through, it goes down, and then it goes up. Now, obviously, we were a little bit off because the graph goes further down here, but I'm not looking for an exact graph. I'm looking for a sketch. If you wanted to determine by hand how far it goes down, you could use a table and like plug in the number 1, and you would see that the graph actually goes past -6 like that. But I'm not looking for that. Okay, obviously, this 0 behaved differently. It bounced off of that x-axis, whereas the other 2 zeros, it passed through. So let's take a look at the equation and see if we can determine what was different about that 0 in the equation that made it bounce off possibly the x-axis. So to the right, I'm just going to recopy the equation. Y is equal to quantity x minus 2 times quantity x plus 1 squared times quantity x plus 3. And I want you to think about this question. Which 0, that does not sound good, behaved differently? Is that the tornado? It's today's Tuesday, right? It's 10 a.m.? No, it's okay.
It's not. Oh, no, it don't matter.
All right, guys, which 0 behaved differently on the graph? Here's where our 3 zeros came from. X equals -3, X equals -1, and X equals 2. Which one behaved differently when you were looking at the graph? The one that's squared, and I actually love Mario's language that she just used. She actually just figured out what it is in the equation that makes this bounce off. The square. If you have a factor with a square, technically at the location of that 0, the graph's going to bounce off of it and make like a parabola shape, like an x squared type shape. So this 0 behaved differently. This 0 bounced off the x-axis. The other ones, we'll just go ahead and make note of what they did. This 0, I shouldn't say bounced off. I should say the graph bounced off. For this 0, the graph bounced off the x-axis. Sam, okay. Versus this 0, the graph passed through. The x-axis. Same with this 0. This one, it passed through. Okay, so hopefully you've made some observations. Let's see if that can help us with the next one. The next one, can you find the zeros, the degree, the end behavior, and the y-intercept? Josh.
There's a quick on post above.
Yeah.
Like the problem is squared.
The factor.
It was like, yeah, the factor is squared in the middle.
Yeah.
What if I like that?
It depends on the exponent. So if it's an even exponent, then the graph is going to bounce off the 0. If it's an odd exponent on the factor, then it's going to pass through the 0. And we're going to write that below. I just wanted you guys to kind of observe it of the last one, and now we'll confirm it. So nice. All right, guys. The zeros. Turn to your partner, find out who has the most siblings, and the person with the most siblings, you share what the zeros would be. Skylar, how many siblings do you have again?
We want to have the same, so I guess we're gonna make.
What'd you say? I couldn't hear you. I have 2.
I said 2.
You have 2 also? Okay.
So can't do the 4.
Then the person with the longer hair. Wyatt, you do it. No, you don't. You have longer hair here. Wyatt, you do it. Skylar, do you know how to find the zeros?
I got it.
I
I
can't.
might be able to, but it would take me like, I would have to redo it a few times to see how to do it.
Okay. It's hard to hear you anyway, so I'll just go ahead and say it. X equals -2 and X equals 1 would be the zeros. All right, guys, bring it up here. You might be further than I am. Sam.
So if the first thing is positive, it's a negative up.
Yes, the end will be up.
And if the degree is negative, it's down. I got one.
You're talking about the leading coefficient?
Like the end behavior.
The end behavior is based off of the degree and the leading coefficient.
Yeah.
So if it's an odd degree with a positive leading coefficient, it's going to go down, up,
Not up, down.
not up, down. If it's a negative leading coefficient, it goes up, down.
Wait, so what's?
All right, guys, let's take a look. So your zero should have been at -2 and 1. Let's go ahead and talk about the degree of the polynomial. What was the degree of this polynomial? The 3, yes, the degree is 3 because it would create an x to the 3rd. If you think about it multiplied out. So the degree is an odd number and it's a positive leading coefficient with positive lead coefficient. You have to envision this multiplied out. So you could technically do x plus 2 times x plus 2 times x minus 1 and multiply that all out, but we only really care about the first term. And if I think about the first term, because the first term has to have the highest exponent, it's going to have to be an x cubed. And because there's no negatives in front, I'm not going to be distributing any negative. So it's going to be a positive leading coefficient. Great question. Okay, so it's an odd degree with a positive leading coefficient. Therefore, how are the ends going to behave? Close. Down, up. Here's something that somebody told me that I thought was pretty helpful. Here's a way that you can remember what we've learned yesterday. Always look at the end. If ever you have a positive leading coefficient, doesn't matter if it's an even degree or an odd degree, the end will always be facing up. Let me say it again. If you have an even function or an odd function with a positive leading coefficient, the end of the graph will always be facing up. Now, if it's an odd degree, they're going to go in opposite directions. If it's an even degree, the ends are going to go in the same direction. Somebody told me that, and that was really helpful. I'm like, oh, yeah, just look at the end of the graph. Okay, now how do we find the y-intercept? Again, that's where x is equal to 0. So we would have y is equal to 0 plus 2, which would give me 2 squared, times 0 minus 1, which would give me negative 1. 4 times negative 1, yep, gives me negative 4. So I have the y-intercept 0, negative 4. Now I'm going to put all this information together. I have x at negative 2 is a 0. X at 1 is a 0. I have the ends going down and then going up. I have a y-intercept at 0, negative 4. I know this graph has to go and hit that y-intercept. Now I need to determine what's it going to do at negative 2. It's gonna go back down. It's gonna bounce off. What in the equation do you think would tell me that the graph's gonna bounce off that? The square, exactly right. Okay, so here's where we're gonna confirm what you guys have already seen. Go ahead and rewrite the equation. Y is equal to quantity x plus 2 squared times quantity x minus 1. Write the zeros down so that you can see it on the graph. This 0 would be at negative 2, and this 0 would be at 1. And here's the key about an equation in factored form. If the factor, if you're like, what's a factor? That's this guy, the thing in parentheses. If the factor has an odd exponent, the graph will pass through the 0. So obviously x minus 1, it's raised to the first power. It has an odd exponent. Versus on the opposite spectrum, if the factor has an even exponent, the graph will bounce off the 0. So obviously you can see this even exponent, which is why the bouncing occurred. If you're saying, what is she saying about bouncing? This is visually what it looks like on my graph. X equals negative 2. We can see it goes up and then bounces off. So that's where the bounce happens.
So on the graph, if it's positive, it just goes.
It goes straight through. So this x equals 1, it came from a factor with an odd exponent, like x minus 1 is where it came from. So it's going to pass through, goes straight through. All right, you have all the information you need to graph the next two. Let's do the next one together, and then I'll have you try the last one on your own. So now, without your calculators, complete the following. Sketch the graph. Do we know what the zeros would be? X is equal to, if we have an x plus 2, what's the 0 at? Negative 2, good. The x minus 1 is going to create a 0 of 1, and the x plus 3 is going to create a 0 of negative 3. Awesome. What's going to be the degree of this function?
4.
Good, it's 4 because we have an x times an x times an x squared. So the degree is 4. That's obviously even. And then do we have a positive leading coefficient or a negative coefficient? So you always look at the leading one, the one in front. So in this case now we have a negative lead coefficient. So awesome, it's going to go down, down. And then now we need to look for the y-intercept. The y-intercept again is where x is equal to 0. So I'm going to go ahead and plug 0 in. 0 plus 2 is 2. 0 minus 1 is negative 1. 0 plus 3 is 3, but I have to square it. A negative times a negative creates a positive. Oh, I have negative 2 times negative 1. Yeah, it's positive because a negative times the negative.
Oh, sorry.
No, we're good. Yeah. And then we had 2 times 9, which will give me 18. This y-intercept, it's gonna go way off my graph.
What's that two is negative?
Because
2 times 1, you do the opposite.
you're thinking of the zeros. The zeros, you take the opposite. For the y-intercept, you're plugging in x as 0. So if I was like really listing this out with all the work, it would be the opposite of 0 plus 2 times 0 minus 1 times 0 plus 3 squared. Check. So what's 0 minus 1? Negative 1. So you want to think about it as like 0 plus negative 1, which will keep that negative. Good questions. All right, let's go ahead and let's put all this information together. So we have negative 2 as a 0. We have x equals 1 as a 0. And we have x equals negative 3 as a 0. The ends of the graph are going to go down and down. The y-intercept, the graph's going to go way up here at 0, 18. It's like way off our graph, but we know it's still part of the equation. What's going to happen at the 0 value of x equals 1? That came from this factor. Is it going to pass through or is it going to bounce off? It's not an even exponent, right? So it's going to pass through because it has that odd exponent. Or you could look at the fact that it has to reach that y-intercept. So it's got to go way up there. Then it's going to come back down. What's going to happen at negative 2? Is it going to pass through? Think about where that came from. Or is it, yes, it's going to pass through because it has an odd exponent. So it's going to go all the way down. And then what's going to happen at negative 3? It's going to bounce off because of that even exponent. So it bounces off and goes straight up, kind of something like that.
How do we know how low to go?
You don't, and we're not concerned with it because it's a sketch. If you wanted to know, you would plug in a number in a table, and then maybe in pre-calculus, but not here. Sam?
Can you just write the like y equals and the grid number again?
The green number? The y equals 18?
Yeah, why is because the negative 1 isn't that negative 1?
It is. 0 minus 1 is negative 1, but because of this negative leading coefficient, we have to take the opposite of positive 2, which would be negative 2, times it by negative 1, which would create positive 2. And then 2 times 9 would give us 18.
Just take the other negative away.
Well, what's a negative times a negative? So that's where it went. All right, guys, you could graph that on your calculator, but you'd have to adjust your window to be able to see up to 18. But you could get a pretty good picture of, hey, how did we do? I'll go ahead and show you how we did, but if you could go ahead and work on the next one, and then we'll see how you did. Yeah. So you don't want to put it on your calculator. You want to try to do it without the calculator here. And then just to let you guys know, this will be on the non-calculator portion of the test. So you're going to see your homework tonight. It says do it without a calculator. You want to use what you've learned to try to do it without the calculator. I'm just showing you how your sketch is pretty close to the actual graph if we put it on the calculator. Like looking at that last one, in case you're interested, this would be what the graph looks like in actuality, which we were pretty close with. It went up, came down, bounced off, and went back down. Okay, but for now, try this last one without a calculator. I'll be walking around to see if we need help with it. Oh. I held that. No, because I gave them August, but. Yes. What? The wires up is going to be giant. It's going to be way off the graph. So negative 2 positive 2. 3 cubed gives you 27. Oh, and then negative 1 to the 4th gives you just 1. Negative 1 to negative 1. Would be negative 1? This would be negative 2, that would be positive 1. So it's going to be negative 54.
Is there homework on campus?
Oh, Mario, I think I told you negative 54, and Sam, it should be positive 54. Because you have the opposite of negative 2.
I'm gonna say the graph looks good.
It should be positive 2. Because you have this negative up here. Okay, guys, after you get it, go ahead and check your work. I'm finding a little bit of confusion about the y-intercept, so I just want to talk about it a little bit more. The y-intercept is always where x equals 0. So if I'm looking at my equation, right now I have y equals the opposite of x minus 2 times x minus 1 to the 4th times quantity x plus 3 cubed. I would plug in 0 for x. 0 minus 2 would be the first parentheses I'm going to evaluate. 0 minus 1 to the 4th is the second one. 0 plus 3 would be the third one, and then I have to perform the operations. So this is going to create the opposite of negative 2. Negative 1 to the 4th will create a positive 1, and then 3 cubed is going to create 27. So this is going to be 2 times 1 times 27, which is where you get that y-intercept of 54. But check to see, did you have the right zeros? Did you have the graph going, starting down, ending down? Did it bounce at the correct location? And that would give you kind of that graph. Jay?
The first orange line on the far left is showing that.
Yes, the other thing that, guys, we still have 4 minutes if we could not pack up yet, because I want to help you with the homework. Something that Jay is also noticing, if you have a cubic, like an odd degree with the power, Sam and Wyatt up here. If you have an odd degree with a power higher than 1, it's going to make a cubic shape around that 0. So that's why I had that orange line kind of like this. It does pass through, but it just passes through in a specific way. I'm not going to require you to show that cubic shape like this, but it's just, it would be part of the graph. Now, speaking of, this is what your homework may look like. This would be an example. It'll say, give a possible equation. So let's see how we would do that. If I give you a graph that looks like this, that has zeros at -1, -3, and 1, and then the graph is going to start down, it's going to go up, it's going to bounce at -1, and then come back down. Do you know how to create the equation from that based off of what you've learned? I hope so. I just want to make sure we know where to start. The first place I would start would be x equals -3. See what 0 that is, and see what 0 this is. This is x equals -1, and this one was at x equals 1. If you have those zeros, x equals -3, x equals -1, and x equals 1, do you know how to put them back into factored form?
Negative.
Good. X plus 3. What would this one be from? X plus 1. And how about this one? X minus 1. Awesome.
Wouldn't they be negative?
So this would be my factors, but then which one should I put a square around? Yeah,
The middle one.
the middle one, because that's where we got -1 from. So that's where I should put the square. The last thing I would pay attention to is, did the graph start up and up or did it go down and down? Down and down. So what should that mean about my leading coefficient? There should be a negative in front. When you look at the answer key, sometimes like I would just be a little bit more specific. So if the graph did look like a cubic shape, something, I don't know, kind of like this around it, like Jay asked about, rather than putting a power of 1 around the x minus 1, I would just put a power of 3. But it doesn't matter as long as you have the odd degree.
What about the y-intercept?
You aren't going to pay attention to that when you're creating a possible equation. Yes. All right, guys. Have a great rest of your day. Your homework is a worksheet. So keep that in mind and make sure you guys know you have 4th period tomorrow. Mario, hold up, guys. Okay, go ahead. Yeah, have a good one, guys. Yeah. Yeah.
What would you say about the difference between?
About what?
What would you say about the difference between pre-calculus and advanced pre-calculus?
So I know that they go at a much faster pace. The algebra is like just way more heavy, like things like that, where they were looking at the y-intercept and everybody was confused about why it's 54. Like they would fly over that, which I'm sure you understood really well. But it's just faster and deeper. But some of the things that you would have missed from algebra 2 are how to factor using fractional exponents. So like when the exponents are 3/2, 1/2, and -1/2, you need to factor an expression with that out, which you haven't seen before. So some of the things, just based off of the way algebra 2 goes, some of the things you would just need to like know, I haven't seen this. I'm gonna have to go back in the book and learn it. Did you make, I didn't have you last semester. Did you make the 96 or above for first semester?
I think so.
You did. Okay, so then you're a candidate for advanced. I'll look at your placement score. I'll talk to Miss Patterson and my department head too and see what he thinks about it. And then I'll get back to you. Is that okay?
Yes.
Because you're thinking about it, right? Advanced? Okay.
Because I know in the past, like in advanced math last year was a little bit of a struggle, but I think.
But you're feeling good? Yeah. Okay. All right. Yeah, I'll look into it. Okay, Jen?